Hello my dear students and welcome to the surface chemistry chapter wherein we are discussing the synopsis regarding the surface chemistry chapter. So in that we were discussing in the previous session we were discussing about purification of the colloids. Okay, so in that already we have discussed the two methods, but still I want to do the revision on that. See, first thing is there are three methods for the purification of the colloidal solutions. First one, what is that? It is called dialysis. Okay, so in the dialysis process what we will be doing, we will take an animal membrane. Okay, in that animal membrane we will be adding our colloidal solution. Now we know that the colloidal solution will be containing dispersion medium and dispersed phase particles. These dispersed phase particles, after absorbing certain charge either by positive or negative charge, they will become colloidal particles. Now see, whatever excess amount of electrolyte is there in the dispersion medium, that has to be removed. Okay, if that excess amount of electrolyte is not removed, again a precipitate will be formed. Therefore, how do we remove the excess of the electrolyte? Now we know that, see, electrolyte means they are nothing but true solutions. Okay, and in the beginning of the class only we have discussed about, in previous session we have seen that the difference between colloidal particles and true solution particles is that true solution particles can pass through both filter paper as well as animal membrane, whereas colloidal particles cannot pass through the animal membrane. Okay, so what we are doing now, we are taking the colloidal solution in an animal membrane. So we know that through this animal membrane only electrolyte can come out, not the colloidal particles. So we have taken this animal membrane and we have added in a tank of water, and in this tank of water, water is continuously flowing from one end to another end. Okay, so when I add the membrane, what will happen? Only the electrolyte, excess amount of electrolyte will diffuse through this animal membrane, and once they are diffused, now water is continuously flowing, therefore the excess of electrolytes are taken away by the flowing water. So inside the membrane what is remaining? Inside the membrane our colloidal particles will be remaining. So simple method for the purification of dialysis. Now this dialysis process is a little bit slower. So this dialysis process can be made faster by introducing the electric field, and this method is called as electrodialysis. So here you can see I have introduced electrodes, cathode and anode. So when we pass electricity, what will happen? The anions will move towards the anode and the cations will move towards the cathode. So in presence of electric field, as the electrolytes are also charged, they move faster. So the process of dialysis will become faster, hence the name is given as electrodialysis. Okay, now here during the purification by the dialysis and electrodialysis, here one thing is to be kept in mind. One thing that we should make sure that excess of electrolyte should not be there, and maximum of electrolyte should not be taken away. ಸಿ ನಿಮ್ಗೆ ಹೇಳಬೇಕು ಸಿಂಪಲ್ ವರ್ಡ್ ಏನಾಗ್ತೈತಿ, ಇಲ್ಲೊಳಗಡೆ ಎಕ್ಸೆಸ್ ಅಮೌಂಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಉಳಿತು ಅಂತಂತಂದ್ರೆ ಅದೇ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ಸ್ ಏನು ಮಾಡಿಬಿಡ್ತಾವ ಅಂತಂದ್ರೆ ಈ ಕೊಲಾಯ್ಡಲ್ ಪಾರ್ಟಿಕಲ್ನ ಪ್ರಿಸಿಪಿಟೇಟ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡಿಬಿಡ್ಬೋದು. ಸೊ ನಾವೇನು ಮಾಡಬೇಕು, ಎಷ್ಟು ಬೇಕೋ ಅಷ್ಟು ಹೊರಗಡೆ ತೆಗಿಬೇಕು. ಸಪೋಸ್ ನೀವು ಮ್ಯಾಕ್ಸಿಮಮ್ ಅಮೌಂಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ಸ್ನ ಹೊರಗೆ ತೆಗೆದುಬಿಟ್ರಿ, ಸೇ ಡ್ಯೂರಿಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಸಿಸ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಅಮೌಂಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ನ ತೆಗೆದುಬಿಟ್ರಿ ಅಂತಂದ್ರೆ ಸೊ ಕೊಲಾಯ್ಡಲ್ ಪಾರ್ಟಿಕಲ್ ಮೇಲಿರುವಂತಹ ಚಾರ್ಜ್ ಕೂಡ ಏನಾಗ್ಬೋದು, ಅದು ಕೂಡ ಹೊರಗಡೆ ಹೋಗ್ಬೋದು. ವೆನ್ ಕೊಲಾಯ್ಡಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಲೂಸ್ ದೇರ್ ಚಾರ್ಜ್, ಇಟ್ ವಿಲ್ ಬಿ ಅಗೇನ್ ಕನ್ವರ್ಟೆಡ್ ಇನ್ ಟು ಪ್ರಿಸಿಪಿಟೇಟ್. ಸೊ ದ್ಯಾಟ್ ಹ್ಯಾಸ್ ಟು ಬಿ ಟೇಕನ್ ಕೇರ್. ಅಂದರೆ ಈ ಡಯಾಲಿಸಿಸ್ ಮಾಡಬೇಕಾದ್ರೆ ಬಹಳ ತನಕ ಅದನ್ನು ನೀರೊಳಗಡೆ ಇಡಬಾರ್ದು. ಆಮೇಲೆ ವಿ ಶುಡ್ ಮೇಕ್ ಶೋರ್ ವೆನ್ ವಿ ಆರ್ ಡೂಯಿಂಗ್ ಎಲೆಕ್ಟ್ರೋಡಯಾಲಿಸಿಸ್ ದ ಕರೆಂಟ್ ದಟ್ ವಿ ಆರ್ ಪಾಸಿಂಗ್ ಶುಡ್ ನಾಟ್ ಬಿ ಪಾಸಿಂಗ್ ಫಾರ್ ಲಾಂಗ್ ಟೈಮ್. ಓಕೆ, so now the third part for the purification of colloidal particle is ultrafiltration. So simple filtration method ada. Okay, so filtration method ada. Idrolagade ನಾವು so in ultrafiltration we are separating the colloidal particles from other impurities. How? By using filter paper called as ultra filter paper. So the filter paper that we are using is ultra filter paper. So what is the difference between normal filter paper and ultra filter paper? In normal filter paper, the size of the holes in that filter paper are little bit larger, Okay, and in case of ultra filter paper, the same normal filter paper is converted into ultra filter paper. So in this ultra filter paper, the size of the holes is made smaller. Only that much difference is there. Now the question comes, how the size of these holes is made smaller in case of ultra filter paper. Okay, so that we shall see. Now the size of these holes of normal filter paper can be reduced by, take the normal filter paper and we have to soak it. What we have to do? We have to soak the normal filter paper in a collodion. So what is meant by collodion? See, collodion is a 4% nitrocellulose solution mixed with a mixture of alcohol and ether. Okay, so now the normal filter paper, which is having a little bit bigger size of the holes in that paper, that normal filter paper is soaking ಅಂತಂದ್ರೆ ಏನು, ನಾವು ಬಟ್ಟೆನ ಹೆಂಗೆ ನೀರೊಳಗಡೆ ಸೋಕ್ ಹಾಕಕ್ಕೆ ಇಡ್ತೀವಲ್ಲ ಹಂಗೆ ಟೇಕ್ ದ ನಾರ್ಮಲ್ ಫಿಲ್ಟರ್ ಪೇಪರ್ ಆ್ಯಂಡ್ ಅದನ್ನು ನಾವೇನು ಮಾಡಬೇಕು, ಕೊಲೋಡಿಯನ್ ಒಳಗಡೆ ಅದನ್ನು ಸೋಕ್ ಮಾಡಕ್ಕೆ ಇಡಬೇಕು. ಸೊ ಸೋಕ್ ಅಂತಂದ್ರೆ ಏನು, ಆ ಫಿಲ್ಟರ್ ಪೇಪರ್ ಏನು ಮಾಡ್ತದ, ಏನು ಲಿಕ್ವಿಡ್ ಒಳಗಡೆ ನಾವು ಆ್ಯಡ್ ಮಾಡಿಲ್ಲ ಅದನ್ನು ಸೋಕ್ ಮಾಡ್ಕೋತದ. ಓಕೆ, ಹೀರ್ಕೊಳ್ತದ. Okay, so the collodion ಏನದು, collodion is actually a mixture of 4% of nitrocellulose solution mixed in mixture of alcohol and ether. ಓಕೆ, ಸೊ ಅದರೊಳಗಡೆ ನಾವು ನಾರ್ಮಲ್ ಫಿಲ್ಟರ್ ಪೇಪರ್ ಸ್ವಲ್ಪ ಫ್ಯೂ ಅವರ್ಸ್ ನಾವೇನಾದರೂ ಬಿಟ್ಟಿವಿ ಅಂತಂತಂದರೆ, ಸೊ ನಾರ್ಮಲ್ ಫಿಲ್ಟರ್ ಪೇಪರ್ ವಿಲ್ ಅಬ್ಸಾರ್ಬ್ ಸಮ್ ಅಮೌಂಟ್ ಆಫ್ ದಿಸ್ ಮಿಕ್ಸ್ಚರ್ ಆ್ಯಂಡ್ ದ ಪೋರ್ ಸೈಜ್ ಆರ್ ದ ಹೋಲ್ ಸೈಜ್ ಆಫ್ ದ ನಾರ್ಮಲ್ ಫಿಲ್ಟರ್ ಪೇಪರ್ ವಿಲ್ ಬಿ reduced. Okay, then we will get ultra filter paper. So now here is a diagram representing. So here I have taken a ultra filter paper, and when I pour the colloidal solution, what will happen? The dispersion medium and other impurities will pass through the ultra filter paper. Now other impurities andre electrolytes. Okay, so now our colloidal particles cannot pass through the ultra filter paper, so they will remain on the filter paper, and other remaining dispersion medium and other impurities will pass through the ultra filter paper. Okay, so in this way, once we separate the colloidal particles, then these colloidal particles are added into a dispersion medium having minimum amount or required amount of electrolyte in it. So in this way, what will happen? The excess of electrolyte is been removed from the colloidal solution. Okay, so these are the three methods for the purification of the colloidal solution. So one thing you should remember, in a colloidal solutions there are two types of impurities. ಮೊದಲನೇದು excess of electrolyte and the second one is soluble impurities. Okay, we have to remove the excess of electrolyte. Why we have to remove the excess of electrolyte? If excess of electrolyte is remaining, then again the colloidal particles they will lose their charge and again they may be converted into precipitate. So that excess amount of electrolyte has to be removed. So these are the three methods to remove the excess of the electrolyte. Okay, so next moving on, we shall see about the properties of the colloidal particles. Let us see one by one. Okay students, now we will study the properties of the colloidal particles. Okay, so among the properties of the colloidal particle, the first and the basic property of the particles is the optical property. Optical refers to light. Optics is a branch of physics which deals with the light. Now what is the optical property of the colloidal particles? Okay, see, these optical particles are the size of the colloidal particles. As we know, it is not very small like true solution particles, and it is not as big as the suspended particles, isn't it? It is intermediate between true solution and suspended particles. Now this makes very special. This is a very special property of colloidal particles. So what will happen is, see, these colloidal particles size is such that they can scatter the incident light on them. Now here is one example. See, this is the source of light. From the source of light, when the light is, this is a colloidal solution. When light enters into this colloidal solution, what will happen? See, the colloidal particles, they will scatter the light. Scattering means, whatever it is, the light is going in one direction, and when it collides with the colloidal particles, the light get dispersed in all the direction. So this is called as scattering of the light. So the colloidal particles, they will scatter the incident light. So when these colloidal particles scatter the incident light, what will happen? The path of the light becomes visible. Okay, the path of the light becomes visible. Okay, so the scattering of light by the colloidal particles, because of which the path or the beam of the light becomes visible, is called as a Tyndall effect. Okay, it is called as Tyndall effect. It was a Tyndall, actually it was Faraday was the first person to study, but later it was developed and completely the theory was given by Tyndall. So this effect is called as Tyndall effect. So what is Tyndall effect? The scattering of the lights by the colloidal particles, due to which the path of the light becomes visible, is called Tyndall effect. And what is a Tyndall cone? Okay, visible path is a Tyndall cone. Okay, so the path of the light which is visible, it is called as Tyndall cone. Okay, now this where you can easily observe is, I hope you all have went into cinema theater to watch the cinema. So there we know that what is happening is there will be a big screen. Okay, there will be a big screen and there will be a projector from which the beam will be falling on the big screen. So here will be a small window, isn't it? Here will be a small window for the projection from which the light is coming. And if the dust particles are there, then little bit the path of the light becomes visible. The little bit the path of the light becomes visible near the projector. Okay, near the projector. So why only this part becomes visible is because of the particles present in that. Dust particles are also colloidal particles. The dust particles present in the gaseous medium, it causes dust particles, isn't it? So dust particles can scatter the light, and because now the light scattered, that path becomes visible. Okay, so this property of the colloidal particles is called as a Tyndall effect, and the path which is visible is called as a Tyndall cone. Okay, now but there is some condition for the colloidal particles to show the Tyndall effect. What are those? The first condition, the diameter, means a diameter, or you can say the size also. Okay, the diameter of the particle should not be too small in comparison to the wavelength of incident light. See, we know that there are so many radiations are there. So every radiation differs from the other radiation in terms of wavelength or in terms of frequency. If higher the frequency, higher is the energy. Higher is the wavelength, lesser is energy. Why? Because frequency and wavelength are inversely proportional to each other. Okay, so the condition is now the size of the colloidal particle should not be too small. If they are too small, then they will not scatter the light. Okay, so in comparison to the incident light, the wavelength of the incident light, the size of the colloidal particle has not to be too small. If it is smaller, then no scattering, then no Tyndall effect. Okay, simple. Second one, the difference in the refractive indices of dispersion medium and dispersed phase particle should be large. Now refractive index means, see, bending of light. The bending of light. I hope this you have studied it. Okay, now the example is, see, when you normally see a stick, wooden stick you take, and when you see in the normal light in the open atmosphere, when you see it, it seems to be straight. When you add that stick, wooden stick, into the a big tank, a glass tank containing water, then what you will observe, you will see that the wooden part which is present in the water. Okay, this also I will show you. Now if you stick the wooden stick like this, it should be like this, but when you observe, you will see that slightly you will see the wooden stick should be, it has bended little bit, it has bended. Okay, so this is why, because the wooden stick has entered into other medium, and when light falls on that wooden stick, it is now bending. When the light enters into, see when the light even enters, when the light enters into, from this is open atmosphere, right? So in the open atmosphere it is traveling like this. When it enters into water, the path will change. Now we expect the path of the light like this. Okay, but when it enters into water, the path of the light changes like this. Again it will bend. So bending of light is called as refractive index of that particular substance. Now there are two particles, one is colloidal particle is present and another is a dispersion medium is present. So the bending ability of dispersion medium and the bending ability of the light by the colloidal particle, they should be large. If they are same, then they will cancel each other. Therefore, I mean, when it is same, you will not see the scattering effect. So the ability to bend the light by the colloidal particles and by the atmosphere in which the colloidal particles are present, the difference should be larger. Okay, that is the meaning. So these are the two conditions to observe the Tyndall effect. Next, application is very important. Okay, this question only they ask in the examination. What are the applications of Tyndall effect? Is, see, our sea and sky appears blue because of the colloidal particles present in the sea and the sky. In the sky there are small solid particles are present which will scatter. Even water vapors are there. That's why we see the rainbow in rainy season. Okay, rainbow is visible and the sky appears to be blue and the sea appears to be somewhere it appears to be green, somewhere it appears to be blue. So the color of these is because of what? Scattering of the light by the colloidal particle. And another is the tail of the comets. Comet, I hope you know. Okay, the tail of the comets is visible because of again the colloidal particles scattering the light. Now this is regarding optical property. So next, so these two examples are very important. These two examples are very important, remember those. Now next property is a mechanical property, and the mechanical property in theory we have studied it in terms of Brownian motion or Brownian moment. So what is the Brownian moment? See, the colloidal particles in a colloidal solution, they are not static. Static andre ಒಂದೇ ಕಡೆ ನಿಂತಿರೋದಿಲ್ಲ. They are always the colloidal particles in a random zigzag motion. Okay, so this zigzag motion of the colloidal particles is called as a Brownian motion. What is Brownian motion? Brownian motion is the colloidal particles are always in a continuous random zigzag motion. This is called as Brownian motion. Now the reason is very important why the colloidal particles are not static, why they are in always continuously moving is because, see, the colloidal particle, they will collide with the dispersion medium particles and other colloidal particles. So this is the reason why they are always in a continuous random zigzag motion. Next one is important, that is electrical properties. Electrical properties means now by this time we know that the colloidal particles are charged. Okay, they are carrying some charge. Either they are positively charged or they are negatively charged. So how the colloidal particles gain that positive charge or negative charge, that we shall see now. Okay, so to explain the positive or negative charge of the colloidal particles, there are different methods are there. I mean, why they are positively charged, why they are negatively charged, there are different reasons are there, but the best reason, okay, so the one of the method by which the colloidal particles will gain the charge on them, that we shall see. Okay, electrical property. In a colloidal solution, dispersed phase particles are either positively charged or negatively charged and the dispersion medium has opposite charge. Therefore entire solution is neutral. Means, see, if I take suppose this is one colloidal solution and the dispersion medium, if the dispersion medium is negatively charged, dispersion medium is negative, then the particles, that is colloidal particles present, they will be positive. Okay, this is the meaning of that. So overall colloidal solution is neutral. This has been very asked many a time. So dispersed phase particles are either positive or negatively charged, then the dispersion medium has a opposite charge. Therefore entire colloidal solution is neutral. It is neutral. Okay, then the charge on the dispersed phase particles can be explained by, now the first method, let us see, which will explain that the colloidal particles have some charge. Okay, first one, that is preferential adsorption. The meaning of preferential adsorption is, I prefer, okay, suppose I prefer a positive charge or I prefer a negative charge. So what is my preference? That is called as preferential adsorption. Means colloidal solutions have they have already decided. Means when colloidal solution have got options, Okay, I mean, when both a positive and negative charge are present in a colloidal solution, then the colloidal particles, they will choose which charge to adsorb. Adsorption you already know. So they will adsorb the charge. So how do they select? Let us see. See, when two or more ions are there in a colloidal solution, means even dispersion medium is also charged, that we know. Okay, so when two or more ions are there in a colloidal solution, then particles means colloidal particles adsorb only that ion which is in common with the particle. What is the meaning of this? Let us study. Okay, let us take one example. Okay, example, see, what I'm going to do is I'm going to add silver nitrate solution to potassium iodide. Okay, so here it is positive, it is negative, it is positive, it is negative. So what is the product that you are going to get? We will get a product of precipitate of AgI. We'll get PPT. We'll get a white PPT. AgI, silver iodide, is formed. Now this silver iodide is precipitated, isn't it? Now there are two types of negative charges will be there. One is NO3 minus and another one is K plus and another one is I minus. These are the three charges, NO3 minus. Okay, these are the three charges which are present in the solution now. Okay, then this will adsorb one. Which it will adsorb? As already said it here, they will adsorb only that ion which is in common with the particle. Now this your particle is silver iodide. So among these three, which is in common with this? This is in common with this particle. Therefore, they will adsorb, AgI will adsorb I minus. Okay, they will adsorb I minus, means if this is your AgI, then I minus will be adsorbed like this. So now your colloidal particle, that is silver iodide, is now negatively charged. Okay, understood? Then next one, if I take, ferric chloride. If I take a ferric chloride and when I add into water, what I'm going to get is, I'm going to get a ferric hydroxide. I'm going to get ferric hydroxide. Now what is left in the solution is your 3Cl minus ion. Okay, 3Cl minus. Okay, along with this will dissociate into what? Fe plus 3 plus 3Cl minus. Yeah, this has also dissociated into like this. So in entire solution you will get what? Cl minus and Fe plus 3, and some of them are Fe plus 3. So what it will adsorb then? Okay, which is in common with this? I mean, if you look into, there are one positive charge, one negative charge is there. So what it will adsorb then? With respect to this is again PPT, precipitate is there. So this will adsorb which is in common with these two. Here this is in common with this. Therefore now this will adsorb. Now this will adsorb Fe plus 3. So now your ferric hydroxide is what charge? It is now positively charged. Okay, then if I take ferric chloride and now I add it into NaOH, then what will happen? Okay, then again ferric hydroxide will be formed. Now here I am not balancing it. Now balancing is not important. What is important? What is the charge is we are getting, that is important. So what is present in the solution? Okay, so Na plus will be there. Na plus will be there, then 3Cl minus will be there, then Na plus OH minus, Na plus OH minus will be there. Okay, so Na plus OH minus will be there. So now if you look into what is in common with this, okay, so if you look, this is again PPT. So among all these three ions, which is in common with this? Now this is in common with this, isn't it? Here is also OH, here is also OH. Now so you will get ferric hydroxide is now negatively charged. Why negatively charged? Because OH minus ion, okay, has been adsorbed. So this questions of this type you will get in the examination a lot. Okay, so this is called as preferential adsorption, means the precipitate itself will decide what to adsorb. Okay, now you know that when silver nitrate is added, I mean say which is in solution, that is important. Okay, which is in solution form, that is important. Okay, so here it is negatively charged, sometimes it will be positively charged, AgI, and it may absorb Ag plus. Okay, so AgI may absorb Ag plus and then it will become positively charged. Okay, so what is being added to what, that is important. Okay, which will electrolyte. Now if I say AgNO3 is being added into Ki, so you will see NO3 minus and I minus. Okay, now suppose I will say that Ki is being added into silver nitrate. Okay, Ki is being added, so what will be I? This will be dissociating into what? Ag plus NO3 minus. So Ag plus ions are there, then Ag plus ions will be adsorbed on this. So what is being added to what? Look into that and decide. Okay, so now this is about preferential adsorption theory. Now we will move on. Okay, that also we shall see. So this is very important, that is preferential adsorption theory. Now moving on to the next part is, we know that even the proteins are, they are also colloids. So what is the charge of the proteins, that also we shall see now. First let me rub this. Alright students, now let us see the different methods which can explain the charge present on the colloidal particles. Like, okay, now the first method that we have seen is preferential adsorption method we have seen. Now the second method is due to the presence of acid or a base. Okay, see, especially this presence of acid and base is applicable for proteins. Okay, so one of the protein is glycine, and this is the molecular formula of the glycine. Okay, so this glycine in acidic medium, it is going to be positively charged. How it is going to be positively charged? This acid is going to dissociate as H plus and Cl minus. Okay, now this glycine or the protein has both, see, this amine is basic in nature, this is basic in nature, and acidic group is carboxylic group, this is acidic in nature. Okay, this is acidic and this is in basic. So when this protein is present in acidic medium, so this acid will dissociate into H plus and Cl minus ion. So this H plus is adsorbed by this base, hence it becomes positively charged. Okay, then if the same glycine is present in basic, then opposite to this will happen. This is Na plus OH minus, then in presence of base, this will dissociate into as COO minus and H plus. This H plus is being absorbed by OH minus and this will become as water. So this is becomes now negatively charged. So certain proteins automatically they will become positive or negatively charged based on the presence of acid or a base. Okay, next, due to the self dissociation. Now this is you have studied in theory part. In theory part, what you have studied, see, we know that the soaps and detergents, they are the stearate ions of sodium or potassium. Stearate ions means they have a long hydrocarbon chain and one functional group that is positive or negatively charged. Like in this case, you can see this part is a long hydrocarbon chain and there is one functional group. Okay. Now when this will dissociate into water, now you can see this thing, this is your stearate ion, which is your colloidal particle. I mean, this will get associated, this will associate with other stearate ions and then it will form micelles. We know that micelles are nothing but associated colloids. So due to self dissociation also the colloidal particles are positively charged or negatively charged. Then comes isoelectric point of colloids. Isoelectric point means, iso means same. Okay, so let us see what is meant by isoelectric point of colloid. See, in case of colloidal solution of proteins, this is applicable for proteins only. Okay, in case of colloidal solutions of protein, there exists a certain pH and above that pH they are negatively charged, above that pH they are negatively charged, and below that they are positively charged. Now and at exactly at the pH, what we are mentioning it, at that point their colloidal solution is neutral, or it is also called as Zwitter ion. Okay, so the pH at which the colloidal solution is neutral is called as isoelectric point of the colloid. Okay, so the pH at which the colloidal solution of protein is neutral or it is existing in Zwitterion. See, Zwitterion means you have to keep in mind which is containing both positive and negative, or acidic and basic groups, you can say, just like this. Here is one example, it is containing both acidic and as well as basic groups. Okay, this is basic group, this is acidic group. Okay, so the molecule which is containing both acidic and basic groups is called as Zwitterion, and this is neutral. Okay, so now our hemoglobin is also one of the protein, and within this range our hemoglobin exists in neutral form, and below this pH again acidic medium goes. In acidic medium it will be positively charged, and when the pH goes above this it will be becoming negative charge. So the hemoglobin within this pH range, it exists neutral. Then comes gelatin, it requires 4.7. Okay, then casein in milk, we already studied that what is casein. Casein is emulsifying agent present in the milk. Okay, so in case of milk also casein is stable in the pH range of 4.1 to 4.7. Okay, so now these are the few methods which will explain why the colloidal particles are positive or negatively charged. Okay, so still few more studies that we have to do in regarding the electrical properties of the colloids, that we shall see. Like what is remaining, see what will happen, that we shall see now. Okay students, now we will see some examples for the positively charged colloids and negatively charged colloids. And easy to remember is that positively charged colloids are hydrated metal oxides such as ferric oxide, aluminium oxide and chromium oxides, and basic dyestuffs. There are three examples I have given: hydrated metal oxides, basic dye and hemoglobin. Basic dye refers to coloring agents. Okay, so the coloring agents which are basic in nature, they are positively charged colloids, and hemoglobin is present in our blood and it is also positively charged. Okay, next is negatively charged colloids. See, negatively charged colloids are what are metal salts such as this is important. Okay, metal salts such as low reactive elements such as what, copper, gold, silver and platinum. They are negatively charged colloids. They are negatively charged colloids. And even metal sulfides such as arsenious sulfide. Yes, they are also negatively charged colloids. Okay, this is important. I think the first point is only important here. Okay, then now basic dye stuff is positively charged, then acidic dye stuff is negatively charged, then other remaining like starch, gum, gelatin, clay and charcoal etc. are negatively charged colloids. The first part only very important, what are positively and negatively charged colloids examples. Okay, next is Helmholtz electrical double layer. Okay, very important from theory point of view. Okay, in CET we should know that already we have studied how the colloidal particles gain charge. Now here I have got silver iodide. Now silver iodide has a positively charged. How the silver iodide is getting that positive charge? Because silver iodide has adsorbed potassium ions, silver ions. Okay, so Ag plus it has adsorbed on its surface, and now this Agi or silver iodide is positively charged. Once the colloidal particles are positively charged by adsorbing certain charge. Now here silver iodide has adsorbed positive charge. So this positive charge again attracts the negative opposite charge present in the dispersion medium. So now our colloidal particle is positively charged. This is going to attract negative charge from the dispersion medium. Okay, so there are actually two layers are formed. Okay, the first layer because of which the colloidal particle is getting certain charge, it may be positive or negative, that layer is called as fixed layer. Okay, and this fixed layer is going to attract the opposite ions, and the opposite ions form second layer around the colloidal particles. That second layer is called as diffused layer, or even it is called as mobile layer. Mobile means moving. Okay, so the first layer is called as a fixed layer and the second layer is called as a diffused or mobile layer. Okay, then So what is Helmholtz electrical double layer? The formation of two oppositely charged layers around the colloidal particle or Soule particles is called as Helmholtz electrical double layer. Okay, then once these two layers are formed, again here I have written positive and negative. This is because in the solution other charges are also present, so those represent that. Okay, next. One thing is important, that what is meant by zeta potential. So zeta potential is, see, these two layers which are formed around the colloidal particles must be stable, isn't it? So if they have to be stable, they have to maintain certain distance between them. Okay, certain distance between them, otherwise what will happen? See, this positive and negative charge, they may combine and they will precipitate again. These colloidal particles may get precipitated. Why? See, what will happen if the distance is not maintained between this fixed layer and diffused layer? What will happen? This positive charge, this negative charge, they will combine and go. Then your silver iodide has no charge. When silver iodide has no charge, then similarly other silver iodide colloidal particles, all of them have lost the charge, so they will start associating and they will form suspension. So this is important, that is in the colloidal solution, if the colloidal particles are not having any charges on them, then they will easily get precipitated. You understanding it? Okay, so this is about fixed layer and diffused layer. Now the difference between the fixed layer and diffused layer, see, this fixed layer has also got certain potential, and potential means this colloidal particles have absorbed, how strongly they have absorbed this. If they have loosely absorbed, then this mobile layer will attract that fixed layer and they will go. Okay, so the potential of the first layer, that is fixed layer, and the potential of second layer, there is some potential or power associated with them. So if the difference between the potential of a fixed layer and a diffused layer is called as zeta potential. It is called as zeta potential. Now the higher the zeta potential, higher is the stability. Lower is the zeta potential, easily they will get precipitated. So this you have to keep in your mind. Okay, zeta potential is very important. Okay, so now next we will move on to the electrophoresis and electroosmosis. That let us see now. Alright students, now we will study electrophoresis. Okay, so in electrophoresis, as you have studied in theory part, so what will happen? See, we have to take the colloidal solution in a U-shaped tube, okay, and in both the limbs we have introduced electrodes, okay, and when we pass the electricity through the colloidal solution, what will happen? We know that our colloidal particles are either positively charged or negatively charged. Suppose the colloidal solution that I have taken is arsenious sulfide, this is negatively charged. So when the colloidal particle is negatively charged, so this will move towards the anode, isn't it? So here the colloidal particle will get discharged, means they will get precipitated over the anode, isn't it? Okay, so the movement of the colloidal particles in presence of an electric field is called as electrophoresis, or the other name is called as cataphoresis. Okay, if the colloidal particles are positively charged, they will move towards the cathode, and when they reach cathode, they will get discharged, means they will lose their charge and they will get precipitated at the electrode. Okay, so now what is the application of this electrophoresis? There are three main applications. One, from electrophoresis we can determine what is the charge of our colloidal particles. Second one, in precipitation of the colloidal particles. Okay, then third one, removing impurities. So electrophoresis can also be thought like it is one of the purification method also. Okay, because once we get the precipitate here, so that once you get a precipitate of colloidal particles, these colloidal particles, once you again add these precipitate into a dispersion medium containing required amount of electrolyte, again this precipitate will be converted into colloidal solution. Okay, so these are the application and what is meant by electrophoresis. Suppose your colloidal solution is having a more amount of electrolyte. Okay, more amount of electrolyte it is having, means our colloidal solution will get converted into what? It will get converted into precipitate, and whenever the colloid is getting precipitated, when colloid gets precipitated, it is neutral in nature. Remember this. Okay, better I'll write colloidal particles when precipitated, they are neutral in nature. This you should remember. They are neutral in nature. Okay, so they will get precipitated when both the times, means when minimum amount of electrolyte is there, when you pass electricity, then our colloidal particles move here on the electrode, they will get precipitated. If already they are having excess amount of electrolyte, then they have already precipitated, then what will happen? Then the dispersion medium will move. What will happen? Then the dispersion medium will move towards the oppositely. Dispersion medium means what? It is also containing excess amount of electrolyte only. So now the excess of electrolyte will move towards the oppositely charged electrodes and they will get discharged at the electrode, isn't it? So the movement of the dispersion medium under the influence of electric field is called as electroosmosis. Okay, so these two phenomena are also important, especially the electrophoresis. Next we shall study about color. Okay, now this already we have seen in the basic thing required we have studied in Tyndall effect. What is Tyndall effect? Tyndall effect is nothing but the scattering of the incident light by the colloidal particles. Okay, now for example, I have milk with me. Okay, say I have milk with me. Okay, now when the normal sunlight is falling and it is getting reflected, I hope you know the meaning of reflection. Okay, when milk appears to be slightly bluish in nature, it will appear when we observe it by reflection of light, means light is coming on it, light is coming on, falling on this, and it is again reflected. So when we observe this, then it is blue in color. Reflected light of the milk is blue in color. Okay, when we observe transmitted color means the light passing through the milk, it is red in color. Reflected is blue in color. Okay, so now the color is changed. Why the color is changed? See, in transmission, what is happening? The light is getting scattered, and the scattering depends on what? The scattering depends on the size of the particle and also upon the wavelength of the incident light. Okay, reflection means simply the light is falling and it is getting reflected. Okay, so transmitted light appears to be red in color and reflected light appears to be blue in color. So color of any colloidal solution depends from what angle you are observing, whether you are observing transmitted light or whether you are observing reflected light. Okay, so this is regarding the color of the colloidal solutions. Okay, then comes the last one for today's session is colligative properties. Okay, now you have already studied this colligative properties in solutions. So you know that colligative property okay, colligative property depends upon number of particles. Okay, now you take one colloidal solution. If you take colloidal solution, there are two parts again. One is colloidal solution. If you take, there are two parts. One is the dispersion medium and other one is dispersed phase particles. Now we know that dispersed phase particles only will become colloidal particles. these only will become colloidal particles. Means see, in this entire solution there are very rare amount of colloidal particles are there. Okay, so whose number is more, whether the dispersion medium particles are more or a dispersed phase particles are more? Obviously a dispersion medium is having more number of particles, so whose colligative properties will be more? So colligative property of dispersion medium is more than the colligative property of dispersed phase particles. Means in other words, if they will ask you the colligative property of which solution is more, homogeneous solution or colloidal solution, your answer is homogeneous. Why? Because in homogeneous there are more number of particles will be there, but whereas in colloidal it is less number of colloidal particles are there. So the colligative property of colloidal solutions is less compared to true solutions or compared to dispersion medium. So this is regarding the electrical properties of the colloidal particles. Okay, so this is enough for today's session, and in the next session we shall go for the precipitation of these colloidal particles, and we shall also study the protective nature of the colloids. That we shall take up in the next session. So let us meet in the next session. Thank you so much, students.